assume Q1 is equal to Q1 and Q2 are perfectly matched and have the following device parameters. And here we have length provided, length 1 meter with 10 length 1 micrometer with 10 micrometer. V threshold is given by 0.7 voltage, and then mu and COX is equal to 200 micro ampere per voltage square, and then lambda is equal to 0. And the question is asking us to find the value of R to get 100 microampere output current. What is the lowest possible value of V0? Okay, so these are the two things we have to find out. Now usually if the MOSFETs are not matched, here they mention Q1 Q2 are perfectly matched, so it means this is going to form a current mirror. Whatever the I reference here is going to be equal to the current right here. But in case if it's not matched, then you have to use this equation. This current, output current, should be equal to the width length ratio, that is whatever the width length we have right here, that is width over length 2 divided by, so we can say I0 divided by I reference. I0 divided by I reference should be equal to width over length of 2 divided by width over length of this one ratio, and you rearrange, you bring the I reference and multiply right here. That will be equal to I0. But this equation is not necessary for this one because they have mentioned this is perfectly matched. So it means this is a current mirror, so whatever the current here should be equal to this current. So we can just write it, I reference is equal to I0 because this is a current mirror. This is perfectly matched. Okay, so that is one information that is useful. And here the question is asking for the R and the V output. V output is nothing but the voltage right here. This voltage is, this is drain. You can see this is an NMOS. If the arrow pointing outward of the gate, that is an NMOSFET. So for the NMOSFET, we have the drain on top, gate here, and then source bottom. So this voltage right here is drain and source voltage. Between this VO is the VDS2 right here. So if you find the VDS2, that is equivalent to the VO minimum. And how we can find the VDS2 is because how we can find it is by considering this is in saturation mode. In saturation mode, this is our what do you call, when we are dealing with MOSFET, our preferred region is saturation mode. So we always assume saturation mode. So here this is, if this is in saturation mode, then this must be saturation mode as well. So to satisfy the saturation mode condition, it has to follow this. This VDS2 must be greater or equal to VGS minus V threshold. And when they say lowest possible, that means V0 minimum. For V0 minimum, this one should be just equal, because that's the lowest possible, and it can be greater, but that's not the lowest. The equal is the lowest one. So that is VGS minus VT. Okay, so we have to find out what is VGS minus VT. Now to find out the VGS minus VT, we have to just use the current equation, because current equation has this term. Let's look at it. I'm going to create a new page, because if you look at the ID current equation, that come with this half Kn W over L times VGS minus V threshold whole square. This is the current equation. And here if we solve for the VGS minus VT, then that's the one we need to find for the V0 minimum. Okay, so all the parameters are available, and the output current, like we have the output current also provided 100 microampere, so we can replace this I with 100 microampere, and then 1 over 2, and this one mu and COX. So instead of Kn, you can also write mu and COX as well, because Kn is equal to mu and COX. Okay, so both of them are same thing. So instead of Kn, you can replace the mu and COX value, that is given by 200 microampere per voltage square. So 200 micro right here, and then width over length ratio, that is width is 10 micrometer and length is 1 micrometer, so that is just 10 over 1. And then VGS minus V threshold is what we are interested in, so we keep it as it is, square. And we rearrange this equation. Here micro cancels, and then this one become 2 times 5 here, so that is 1000. So 100 divided by 1000, 100 divided by 1000 is equal to the VGS minus V threshold whole square. Therefore VGS minus VT is nothing but square root of 0.1, and if you find that value you will end up getting 0.3 voltage. Okay, this is the VGS minus VT, which is also equal to V output minimum. That is also approximately 0.3 voltage, and this one is, if you find this one, you're gonna end up getting like 316 or something, but you can approximate it to be 0.3. okay, so this is our V0 minimum. Now once we have the V0 minimum, that's our VDS voltage. Okay, so here from this one, if you want to find out the R resistant, we have to know what's the voltage right here. And if you see the first Mosfet, that's diode connected, so it means whatever the voltage at gate should be equal to whatever the voltage right here, because this is diode connected, so this voltage is right here. This is nothing but gate, the voltage right here is gate to source voltage. So if you solve for the gate to source voltage, and gate to source voltage for both of them is same thing, because it's both of them are connected like this. So if you find the gate to source voltage, that's the voltage we are going to have right here. So we have to just solve for the gate to source voltage, and we can solve it from this equation right here. Here we found out VGS minus VT to be 0.3 voltage, and VT is nothing but the V threshold that's provided in the question. So here it just rearranges. So 0.3 plus VT, which is 0.3 plus 0.7, that's equal to 1 voltage. So the voltage we are going to have right here is 1 voltage. If this is 1 voltage, then this one must be 1 voltage as well, because this is diode connected. So now we can solve for the resistance, because if you look at the current equation, like this voltage minus this voltage divided by the resistance in between should be equal to this current. So we can create an equation using that. So let's create in a new page. So 3 minus 1 divided by the resistance in between should be equal to the I reference, and we know the I reference current that's provided in the question, 100 microampere, that's the output current, but that's also equivalent to I reference because this is matched and this is current mirror. So whatever the current here is exact same current here. So the I reference is 100 microampere, so we have to just plug that one in. So 2 over R is equal to I reference, that's 100 microampere. Therefore R is going to be equivalent to 2 divided by 100 micro, which is equivalent to 20 kilo ohm resistance. Okay, and that's our R value. So now we found out the V output minimum, that is basically VGS minus V threshold, and we found out the R resistance, that's 20 kilo ohm resistance. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys.